Here is an example with complex numbers series. I hope you find it interesting. Master Strategies with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We have been serving you absolutely free for the last 15 years with excellent quality material. Let me thank all the viewers and subscribers for watching our videos, posting excellent suggestions and comments. In this video, we have taken up another excellent question which has come in past test papers for IB students. Let us see how do we find the sum of the given series. The question here is prove that the sum of the series I to the power of r, where r goes from 0 to n, is 1 plus I times 1 minus I to the power of n plus 1 divided by 2. I is a complex number which is equal to I square is equal to minus 1. Very interesting question. You can always pause the video, answer, and then look into my suggestions. So let's also understand few concepts before getting into the solution for the question, which is the sum of a series which is from r equals to 0 to n for I to the power of r, which really means I to the power of 0 plus I to the power of 1 plus I square plus I cube, right? And so on till I to the power of n, correct? Which you would also write as I to the power of 0 is 1, right? And I to the power of I, 1 is I. And then we just keep them as such here, these powers of I up to I to the power of n. So what does that remind you? Well, it looks like a geometric series, right? So let's look into review geometric series, correct? So in geometric series, if we have AR, AR square, right? And if we want to find the sum, so let me write down the sum of these, right? So A plus AR square plus AR to the power of 3 plus so on to AR to the power of n. So we have n terms, and therefore the sum of the series for n terms is given as A into 1 minus r to the power of n divided by 1 minus r, correct? So if you compare what we have in hand here, what do you notice? Well, we see that A is equal to 1 for us, right? So A is 1 and R is equal to I for us. Every time we are multiplying by I. And what are the number of terms? Since we have used n in the series itself, I'll use capital N. So the number of terms actually are n plus 1. So this is to be noted, right? Since we are starting from 0, you see, we are starting from 0 to n. So we have n plus 1 terms. So clearly we can straight away apply this particular formula and get our answer, right? So what do we get here is that this series is equal to a being 1, so I'll just write 1 here in brackets. No need to write, but I'll write to show 1 minus r is I for us, to the power of number of terms which are n plus 1, correct? Over 1 minus r. So we get this sum. Is that clear to you? Right. So now you will notice that we do have something common to our formula, which we are looking forward to. Now, to get 2 in the denominator and 1 plus I, we have a very simple step to move forward. And so we'll do rationalization, right? 1 minus r to the power of n plus 1 is already there, divided by 1 minus I. What should we do? We should multiply and divide by 1 plus I, correct? So as soon as you do that, we do get in the numerator the term required, which is 1 plus I, And we also have the other term, which is 1 minus r to the power of n plus 1. Correct. Now the question of denominator, which is in this case 1 minus I times 1 plus I. Correct. So what is 1 minus I times 1 plus I? Isn't it equal to 2? Well, for those of you who have not really worked much with I, let's do it, right? So 1 minus I times 1 plus I, right? So if I multiply, I get 1 minus I square, right? Since we know I square is minus 1, so it is 1 minus minus 1 and it's equals to 2. Do you see that? So the denominator is indeed 2 and therefore we get that also. And therefore we can say that this sum of the series, which is from r equals to 0 to n, right, for I to the power of r is indeed equal to 1 plus I, right, times 1 minus I to the power of, I should have written I here, right, not R, right, I to the power of n plus 1, correct, over 2, correct. You see that. So that is how we are going to complete the solution. So I hope it's absolutely clear how do we get the answer, right? So rationalize it, and you know 1 minus I times 1 plus I is indeed equals to 2, right? So that is how we will actually do it. I hope the steps are absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. A request from Anil Kumar. Feel free to support our channel whenever possible. Thank you and all the best.